Right, hello everybody. This is the session this morning, the time 27th of April. So just going to see whether I can share the screen with you. Want to get into this box here, and then I want to access something called Desmos, which is there. Desmos is a graphical calculator. So here it is. Now what I want to do is I just want to change the settings to degrees, because what we want to do is obviously have the horizontal axis going up in degrees, and we want to change the y-axis to something nice and simple, whole numbers from -5 to 5. So there we go, it's all set up. No, it's not set up. What happened there? Oh, 3,600. There we go. Right, so it's all ready to go. There it is. Now, let's try the graph y equals sine x. So that's the shape we know and love. Notice that the horizontal axis goes up in 20s, 20, 40, 60, 80, 100. So this is 90, this is 180, this is 270, and this is 360. So that's the sine wave. Now this topic is all about transformation. So the question is, what would happen if I copy that same function? It's now gone blue, but there are two. There's a red and a blue one. The blue one exactly overlaps the red one. If I want to add something to this curve, like 1, you'd probably expect it to move up one place. So if we have a look closely, the y value here is 1, and this is 2. So the whole original red curve has shifted one place up. So this lowest point here has moved one place up. So this point here, 270 minus 1, this point here would be 270, 0. So you would have added 1, so it's moved up one place. This point has moved up one place. This point has moved up one place. In fact, every single point on this curve has moved up one place. And if we carry on, we can move the sine x graph up and down however we want. So -4. So there it is. So we're moving the original graph in red, okay? This will go down 4 places, 2, 4, and every point will go down 4 places. So this is what we call a translation. This is a translation, and it's a translation parallel to the y-axis because the movement is going up and down parallel to the y-axis, okay? Now, what we need to do next is to consider what would happen if we try to move things going across in the x direction. So let's have a go at this. What I want to do is start with the sine x curves again. And this time we're going to type in something else. Let's try sine x minus 30. Now you can see that purple curve has already moved. Now, it doesn't do what you expect it to do in the x direction. The y direction, the one we've just done, it does exactly what you expect it to do. If you add 3, it goes up 3. If you take 4, it goes down 4. But when you replace x with x minus 30, the unusual thing that happens is the red curve moves 30 degrees to the right. So this point here, of course, has moved 30 degrees. And you'll find that that's the case with every point. So this point here, of course, is 91. Let's get the sine curve. There it is, the 91. And if we move across, this point here will be 121. So we'll just go back to the highlight there. There it is. So every point on the curve has moved 30 degrees to the right. Every point has moved 30 degrees. There's the red curve, 30 degrees to the right. There's the red curve, 30 degrees to the right. So when we replace x with x minus 30, the opposite happens. We don't move 30 to the left, we go 30 to the right. Let's try this one. We'll start with sine again, and this is the original curve x, and we're predicting that if I add 90, the graph should go to the left, and it has. So here is the original graph, sine x. The maximum here is 91. If you take 90 degrees away in the x direction, the 90 becomes 0, and it will move to here, 0, 1. There it is. And that's the case for all points on the curve. So if you just have a look at this one, we've said this one moves across, and it goes across there. This point, okay, would go to minus 45 here, minus 45. Very, very difficult for me to, oh, there it is. No, nearly. Minus 45 degrees, there we go. So it's moved across 90 degrees. This red point has moved 90 degrees to the black point. So every curve on the red thing has moved, every point on the red curve has moved 90 degrees to the left. So there, from there to there, from there to there, from there, whoops, can't do that one, from there to there. And from this point here to that point there, more or less, 90 degrees to the left. So just to summarize what we've just done here is we've done translations, movements going across in the x direction and vertically up in the y direction. Now let's just put these two things together. Let's type in y equals cos x. I'll drop the brackets for a minute. And let's consider what would happen if we do a combination of the two things. So we've got x being replaced with x plus 60, and we're just taking 2 off the end. Well, it should be obvious that if we go back to the red curve here at 0, 1 has moved to this point here. Okay? And you'll notice, first of all, that it's moved 60 degrees to the left. So I'm just going to insert another graph here so you can see that this graph is made up of two things. There it is. So I don't want that just for a minute. That just makes it a little bit confusing. Let's try again. So y equals cos x plus 60. So if we have a look at the red graph, the light red graph, we know that the original cos graph has moved 60 degrees to the left. Okay, there's the peak, it's moved 60 degrees. So every point on the original curve has moved 60 degrees to the left. Okay, so remember this is minus 90. Take 60 as minus 150. And then these points have moved down 2 places. So you can see that to transform this function to this, you're doing it in 2 stages. You're doing a translation in the x direction first, 60 degrees to the left. And then when you add on the minus 2 at the end, it brings the graph down 2 places. So if we just summarize from this point here, it goes across 60 degrees to this point here, then it moves down 2 places. If we pick another point, this point here, that's at 90 degrees. If we take 60 away, we get to this point here, 30, 0. And if we take away 2 in the y direction, it goes down to 30 minus 2. So that's the combination of translations in the horizontal and the vertical direction. So I'm going to pause there.